Hello guys and welcome back. So now I have cached this geometry and removed the color attribute. The way the environment is set up is using a copy node like I showed, and after we set everything up, I'm just gonna transform this here and then merge them together. The reason I'm going to use a transform node is because we want to change the name of this, and if we look at these values here, you see the name attribute. This is it. This is what the Voronoi node is doing, and then if we transform that and merge it back, the name will collide basically, so we have to change it. And the easiest way to do that is prepending a string to these copies. So I'm going to say @name is equal concat for concatenation, and then I want to concatenate the name attribute, the current name attribute, with an extra word, which is copy1, for example. Let's take a look. Let me check something super quick. Oh, it's a primitive attribute, not point attribute. Cool. So it's adding this, and concatenation is just taking the existing string, which was this portion here, and then adding this guy. And with this now, I can just combine them together and pass them to the RBD object, and they will work just fine. If we didn't do this, the sim will explode because it will not know how to deal with the pieces. Let's do a copy here. Let's do one more. Control Shift a click to visualize the mesh. I'm gonna do the same thing, and this is copy 2. I'm gonna merge all these, and I'm gonna assemble that. And let's make a switch, so we can easily switch between 1 or 3 blocks if we wanted to test things quickly. And let's go back inside the sim. Now, one thing that I always do is I run a sim before I start adding any constraints or anything like that, and if there is any issues, you will see them here, because the main thing that you'll probably see if there's an issue is you'll see the sim exploding after certain frames, or just a piece fly off. That means you don't have proper collision. You have something intersecting that causes bullet to behave like that. Cool. So everything's working and falling down as expected. Let's go back. Set this to 1. Pardon me. And at this point, we're going to start creating the constraint networks. Now, I want to clean the data a bit, and any attribute that I don't need, I'm going to remove. Let's delete the rest. Let's delete the class. These two we need. Okay, and let's delete groups. I don't need any grouping at this point, except the inside and the outside. Cool, so this symbol here, Shift 6 key, it means delete everything except this and this. Okay, so I have the data prepped here, and this is where I'm going to use do the connect adjacent pieces. So points adjacent pieces from surface. So something is not right. Something is not working as expected. See the constraints here? This is fine, but these guys are not working as expected. Let me try with the packed primitives and see if that helps. Nope. So let me investigate why. Actually, let's just try this. Let's try one of them and see how it works. We may have the main, yeah, this is working fine. The main reason for this not to work is if the name is overlapped. So it doesn't know how to link the pieces together. This one looks good. This one looks good. Then we're gonna have, yeah, so this name, we forgot to change it in these two blocks. So arch, I'm gonna call this pillar. And this one top. Cool. Yeah, if you see any issues with the connect adjacent, it's because the pieces are not set correctly. So now we should see a network. Cool. Yeah, this is what I'm looking for. And it's connected here. And remove this guy. Let's call this out CST for the constraints. And let's create the wrangle node and set the constraint name and constraint type. So I'm going to call this glue. Constraint type all. And let's create a sphere to test with. So we can hit this structure. I'm going to call this out sphere. Okay, let's go back in. Constraint network. Again, we specify the out CST and then a glue constraint node, and the data name is glue. Something is not. Yes, the run over type, the type needs to be a primitive type, so the constraint can be recognized. There's something here with the connection. I'm not sure why that's happening, so I'll go and check the mesh later. But for now, let's add that RBD object and merge them here. Everything gets fed to the first input. And let's do out sphere. And give it a positive z-axis. Let's try 20. I'm going to hide the network. The other direction, let's try 100. Cool. And as you can see, it's pretty fast for dealing with all this at the same time. I think this piece didn't get fractured. That's why the connection was linking to all this. I think there is nothing wrong with this, just this long piece didn't break, didn't have enough fracturing, so we can go back and add extra points here. Actually, I will do that. Let's take a look at the animation again. So everything is working perfectly, no issues so far. So let's go back here. I want to add some geometry to that part, and let's do this. Let's select this part and just remove it. Delete non-selected. And I'm going to clip it to close the top. So just with the clip node, it's easier to get that nice flat edge. Delete below, and then the poly cap node, and there we go, it's enclosed. So let's do a VDB, let's copy this and make sure we get plenty of points in there. I don't need to be very fancy here, so just 20 points should be enough. And let's take a look. Let's turn on the visualize pieces. Cool, so we have more details. Now with this, if you want to view the colors per piece and you don't have access to this, to the Verna, you can just set a color node random from attribute, and the attribute is name, and it's a primitive attribute, and that will give you a random color based on the given attribute. Okay, let's save this, and let's switch this to 0, so it accounts for all the guys together. And let's take a look at the connectivity network. Cool. Yeah, I wanted to see it connecting everything. And I'm gonna move the geometry here. This guy. And I'm gonna give it a different angle. Let's try 100 on the X. Obviously the wrong direction. And we didn't pin anything on this structure, so everything is interacting together. Cool. So in the next video, we're going to set up introduce the pin constraint in an interesting way, and then we're going to look at the forces. Thank you guys for watching, and see you in a bit.